Hey everyone, welcome back. We are on Unit 4, Day 4 notes, and today's focus will be problem solving with slope-intercept form and equal parts problems. So our goal is that students will be able to translate word problems using slope-intercept form and equal parts in order to solve for the missing information with 80% accuracy. So, in order to do this, we have 5 steps that we can follow. Our first step is to label the variable or what you're looking for. So we're going to read through the problem, identify our variable, and label it. The second step is to identify key pieces of information within the situation. Our third step is to enter the information into an equation and then solve. Step 4, check your answer. And step 5, write a complete sentence. So we're going to follow these steps when we go through the next few examples. Okay, so let's get started. Translate the following word problems into slope-intercept form and solve. And again, that slope-intercept form follows a specific pattern. When given a word problem with a total, we can translate to slope-intercept form using the following. So our total, let's try that again. Our total equals the rate times our variable plus a starting amount if we're given one. So, do my best job to color code this here. Let's read through the first situation. So Ken figures that homecoming will cost him $160 total. If he has already saved $46 and earns $6 per hour at his job, then how many hours must he work to save enough money? So, right off the bat, we want to identify our variable. Now, it's asking us for how many hours he must work. So our variable, what we're looking for, x, is the number of hours. Okay. Next, we're looking for our rate. And we can identify our rate when we see the information and then it says per hour or for each or for every or some scenario like that. In this situation, it says $6 per hour. So our rate is $6 and that's each hour that he works. Next, we have our starting amount, which I'm using purple for. And when we look through this, it says it will cost him a total of $160, but he already has $46. So that's the starting amount, what he already has before he started to work and earn additional money. And then last but not least, we have our total. So homecoming will cost him $160 total. Okay, now all we have to do is plug this information in. So if we follow our formula, total goes first, which is $160, equals our rate, which is $6 times our variable, x, which represents the number of hours he must work. And then we are going to add in our starting amount of $46. Okay, so the next thing we must do is solve. Right, we set up the equation, and now we need to solve for x. So to isolate that x term, we need to subtract 46 on both sides. 160 minus 46 gives us 114. We are left with 6x, divide by 6, and we are left with x equals 114 divided by 6 is 19. Now, 19 what? We cannot leave it right there. What is the question asking? How many hours must he work to save him enough money? So we say Ken must work 19 hours have enough money. And that's our final answer. All right, let's go ahead and take a look at number 2. Amanda wants to buy a new bike that costs $250. Her parents give her $75 and she earns $25 a week at her job. How many weeks must she work until she has enough money for her new bike? $25 a week. That is not a high rate, but it is a rate for us to use. But let's go ahead and let's go in order. So we're going to identify our variable first. It says, how many weeks? That's the missing information. So that's our variable. It's number of weeks. Then let's take a look at our rate. Our rate, we talked about this in the previous problem. We look for the information that's associated with something such as per hour. In this situation, it says a week or each week. So each week, that rate is $25. Our starting amount, or Amanda's starting amount, wants to buy a new bike that's $250. Her parents give her $75. So before Amanda works and earns any money, she has $75. And then the total is $250. That's the total that Amanda needs to get to in order to buy the bike. So let's go ahead, set it up. The first thing we need, according to our outline up here, our formula is total equals rate times variable plus our starting amount. So our total, $250, equals our rate, 25, times our variable, which is x, plus our starting amount, which is 75. All right, we have plugged in all of our information. Let's go ahead and solve. So to isolate the x term, we must subtract 75 from both sides. We get 250 minus 75 gives us 175. Left with 25x. We divide by 25 on both sides. And we get x equals 175 divided by 25, which is 7. So that's not our answer. Our answer is 7, but we need to put it in sentence form so that we know and we show what the 7 represents in the situation. We know x equals 7, and x is our number of weeks. Therefore, we say Amanda must work 7 weeks to buy the bike. Beautiful. All right, pause the video here, take a few minutes, try problem number 3, and then we'll come back, go over that, and then move on to the next part. See you in a few. All right, welcome back. So check out your answer. Mary is driving at a rate of 30 miles per hour and has already driven 275 miles. How many more miles will it take to drive a total of 725 miles? So again, that question, how many more hours? So that is why x is number of hours. Then we have our rate. It says 30 miles per hour, right? For every per, that's going to indicate our rate. Our starting amount says that Mary has already driven 275 miles. And then we have our total needing to complete the trip is 725 miles. So the final answer is Mary will have to drive 15 more hours. All right, let's go ahead and take a look at our next section, which is going to discuss a different method. So when given a word problem that is asking to solve for when two sets of information will be equal to each other, we can translate using the following. So those two sets of information, that's going to represent by person or a thing, and we're going to call that person or thing number 1, and then that should be equal to person or thing number 2. Okay, some key pieces of information here to pay attention to. Keywords: the word saves represents addition, the word spends represents subtraction, and then when we see same, that's indicating equal to each other. All right, let's jump down here to number 1. So Jenna has $110 and is spending $6 per week. Nicole has $30 and is saving $14 per week. When will they both have the same amount of money? So we're looking for some information here to see when they will be the same. We are looking at the how many weeks. So our variable is after how many number of weeks will they have the same amount of money. So when, that's our timing, and we know that they're dealing in weeks. So Jenna has $110 to start and is spending. Spending means subtraction, so subtracting $6 per week. Then we have Nicole has $30 and is saving, so that's adding $14 per week. Now we have our equation. We have 2 parts or 2 things that are equal to each other, and we go ahead and solve. So I'm going to choose to add 6x so that we can avoid working with negatives. And we get 20x. Going to subtract 30. We get 110 minus 30 is 80. And then we're dividing by 20. And we're going to get x equals 4. So again, x equals 4. That's good that we see what x equals, but now we have to write into a sentence so that we can tell what it represents. And we will say Jenna and Nicole will have the same amount of money running out of room after 4 weeks. Okay. All right. Number 2. AT&T has an activation fee of $18 and charges $45 per month. Verizon has an activation fee of $48 and charges $30 per month. In how many months will the cost be the same? So, in how many months? So, number of months. All right, let's take a look at AT&T first. So, AT&T has an activation fee of $18 and charges $45 per month. So because charges you might think means subtraction, but we are finding a total amount of charge that AT&T and Verizon is. So we are combining our $18 charges with our $45 a month charge. So that's why it is addition. Verizon has an activation fee of $48 and charges $30 per month. Okay. So let's go ahead and solve. I'm going to subtract 30x from both sides. And we get 18 plus 15x equals 48. Then we subtract 18 from both sides. We get 15x equals 30. Then we are going to divide, carry this up here. 15x equals 30, divide by 15. we get x equals 2. So we need to write it in a complete sentence. We will say, I'm going to start this one farther to the left so I have enough room. The cost for AT&T and Verizon will be the same after 2 months. Barely have enough room this time. Okay, pause here. Try number 3. Come back, check your answer. See you in a few. Okay, welcome back. So, Lisa has $100 and saves, so that's why we are doing 100 plus 10x per week. And Bart has $200 and spends or subtracts $15 per week. They are parts that are equal because it's saying when are they going to have the same amount. After we solve, we get x equals 4, which then our final answer will be Lisa and Bart will have the same amount of money after 4 weeks. Awesome. Thank you so much for tuning into this set of notes. I hope you have a great rest of your day. Peace out.